everyone, this is Joy from DeepComputing. Today I'm going to show you the state of the RISC-V web platform, Chromium and Node.js progress. So I don't know how many of you guys know about DeepComputing, so let me do a brief introduction. DeepComputing is a startup company focused on RISC-V. We do RISC-V laptops, pads, and we also make some RISC-V powered fun gadgets, toy cars, and balloons. So in 2023, we make the first generation of our own RISC-V laptops. And in 2024, we make the second generation, and it's 8-core, 1.75 gigahertz, which all can run Ubuntu and Fedora. But after doing 2 generations of our own laptops and pads, we realized that for a startup company like us, it takes a lot of time and money to do this. So we decided to partner with Framework. Framework is a company that they make repairable and upgradable products. It also supports multiple ISA, so whether you can use x86, ARM, or RISC-V. So from that, we focus on making RISC-V motherboard for them. That coming out, the first generation of the RISC-V motherboard we made for Framework laptop. It's 4-core and 1.5 gigahertz. And then in the same year, in October, we make the second generation. And it has up to 50 TOPS and can run AI locally. And then it's the latest generation. It's 16 cores and has up to 16 TOPS AI, which also supports RVA23 profile. For those who are interested in this product, can come by to our booth in the 3rd floor. Now let me introduce Bruno, a senior developer relations engineer who has been working on bringing Node.js for RISC-V. Bruno maintains the unofficial build for RISC-V 64-bit, providing ready-to-use packages and binaries for Node.js. He could not be here today, but he prepared the following slides to show the current status of Node.js and Chromium on RISC-V. So before we dive into the details, let me explain why this talk covers both Chromium and Node.js. The answer is V8. So V8 is Google's open source JavaScript and WebAssembly engine, all written in C++, and is a heart of Chromium, where it runs JavaScript in the web page, and Node.js, where it runs JavaScript on the server side. So when V8 is ported to RISC-V, both platforms can benefit from that. So let's look about the V8 JIT pipeline on RISC-V. Ignition is a ByteDance interpreter. Sparkplug, the baseline JIT, gives faster startup. And Turbofine, the optimizing JIT, has peak performance. The gap is Megalove, the mid-tier JIT, which is not yet ported to RISC-V. That means there is a performance cliff between the baseline and optimized code. WebAssembly also ports to RISC-V with SIMD mapped to RISC-V vector extensions. So Node.js classifies RISC-V as experimental. That means there's no official binaries on Node.js.org, and test failure does not block release. The good news is upstream issue 2876 was closed as completed in February 2026, so it's now officially recognized. Technically, V8 is well ported to RISC-V. Both Turbofine, the optimizing code, and Sparkplug, the baseline JIT, and WebAssembly also works. Historically, the issue is OpenSSL no ASM build flag, because there is no RISC-V assembly in OpenSSL. But this issue is now resolved in OpenSSL 3.1. So how can we move to Tier 2? we need permanent CI machines in Node.js build pool and committed maintainers. So hardware vendors and community members can help here. Since there is no official Node.js build for RISC-V, so Bruno created the unofficial build project that fills this gap. What makes this project special is that it runs the entire build natively in a real RISC-V hardware, a Banana Pi F3, using 8 core and 15 GB RAMs. This project has already built and released. Node.js 22 is a LTS line, and Node.js 24 the current line. The pipeline is fully automated with a GitHub Actions self-hosted runner, and the runner is the RISC-V machine itself. So how can you download Node.js? First, from GitHub release. Second, use apt repository for Debian and Ubuntu. Third, use RPM repository for Fedora. Everything is GPG signed for security. So here is how the build architecture works. It runs the entire build natively in a real RISC-V hardware, the Banana Pi F3, rather than cross-compilation. The self-hosted runner on Banana Pi 3, it downloads Node.js source and compile with make using Ccache, generate Debian and RPM packages, and create GitHub release with artifacts, and automatically update apt and RPM repositories. So now is a trade-off. Cross-compilation takes only 30 to 45 minutes, while the code-native builds, the first time without cache, takes 8 to 12 hours. This is the current reality of RISC-V hardware, but with a warmer Ccache, the subsequent builds takes only 14 minutes, and we get the crucial benefits of testing in a real RISC-V hardware. So let's look at the full Chromium browser. Like in previous slides, V8 is well ported to RISC-V. But a Chromium browser is much more than a JavaScript engine, and there is no RISC-V bot in Chromium CI system. That means RISC-V build breakages will go undetected until community members cache them. Beyond V8, several efforts are needed in specific RISC-V. And all existing Chromium build for RISC-V comes from community efforts. OpenSUSE was the first distribution to build Chromium for RISC-V back in 2021, and OpenOiler port version 100 and 103. And the RISC-V Folks project, they provide CI system that catches RISC-V build breakages. And Xuantie, the Alibaba RISC-V team, contribute to the performance optimizations for RISC-V. So let's look at the real performance numbers. On Speedometer 2.0, the RISC-V machine scores about 9.75, while Raspberry Pi 4 scores about 17, and Pi 5 scores 16.3. So we are roughly half the speed of Pi 4 and 7 times slower than Pi 5. For WebGL, our DeepComputing DC Roma 2 hits 14 frames per second, while in Firefox it manages only 16 frames per second. That's because Chromium has better GPU accelerations on RISC-V. So how can you contribute to Node.js and Chromium? Download it. If you have RISC-V machines, you run it and test and report to upstream. Second, if you are a hardware vendor or have spare boards, consider sponsoring to the CI machines to the Node.js build pool. And you can also use Bruno's unofficial builds. The last one is our DeepComputing's 100 open source project for RISC-V support. We provide RISC-V hardware for your project. So for those who are interested in this project, can go to our web page or can just come to talk with me. And for those who would like to know more information about RISC-V and deep computing, can follow us on Twitter and LinkedIn. That's all. Thank you.